Okay, so I just wanted to make a quick video talking about the two samples problems that we're going to be looking at now. For Unit 7, we look at two sample problems, and if we have time, we'll get to the chi-square and the regression equation hypothesis testing. I'll talk more about those in some notes. We might not have to get to those this year, but we will have to get to the two sample test. And one of the main differences is that it is two samples compared to one sample, so your null and alternate will look slightly different. This is a basic example of just, I have the null, the proportion. You should always have them labeled. Now that we have two, and I just have little subscripts M and W for men versus women. So I have the proportion of men is equal to the proportion of women for the null. For the alternative, the proportion of men is not equal to the proportion of women. And what I want you to think about in this video, this is very important, more for the confidence intervals than the hypothesis testing. This is good to look at so you can write out your conclusions and talk about the alternative correctly if we have evidence for or against the alternative, saying that there is no change, there is a change, that the support to claim that men is larger than women, the proportion. But when you're looking at confidence intervals, knowing this equation, the algebra of the equation, is important. So if we're looking at just the basic algebra for it, if we just have the equation, the pi of men equal the pi of women, in some problems, you're going to see the null and alternate written as the difference, because that's what we're looking at. We're looking at comparing the two. So if we do the algebra, if I wanted to get the difference here, I'm subtracting women from both sides, or the proportion of women from both sides. So I would have pi of women, or minus pi of women, minus pi of women on both sides. That cancels out, and what we're going to be left with is pi men minus pi women equaling 0. And first, when we're talking about confidence intervals, what I want you to think about is this equation here, this expression here: proportion of men minus proportion of women. Okay, if these were the same and you subtract it, you would get 0. So that means 0 should be in your confidence interval. Anytime 0 is in your confidence interval, we're going to say that there is no difference, there is no change, even if it is just barely in the interval. If 0 is inside that interval, we're saying that there's no difference. Now, if there is a difference, that means either the men proportion is higher or the women proportion is higher. You need to think about what those numbers would be. If the proportion of men is higher than the proportion of women, think about this problem. Men minus women, if men is higher, you're always going to have positive values. If the women is higher, that means the men is lower. If you are taking and subtracting a higher value away from a lower value, you're always going to have negative. Okay, so you really need to think about, what does that mean my interval is going to look like? Well, if we're going to say the men proportion is going to be higher, and the difference is that the men is greater than the women, that means my interval is going to have to contain all positive values, because no matter what the difference is, men is always going to be higher, so it's always going to be a positive value. If we're going to say that the women have a higher proportion, meaning pi of W is always going to be greater. Well, if pi of W is always greater, that means in this subtraction problem, it will always be a negative value. So if your interval contains all negative values, that means that the women proportionally are going to be higher. And that's the evidence, that we have evidence that the women are going to be higher. So this equation here is very important when we're thinking about the positive and negatives for the confidence intervals and coming up with a conclusion for them. Okay, the entire thing here, including the equals 0, that's not going to be important when we start looking at the two samples more for the averages. Okay, but you may see sometimes, I'm going to tell you this now once so you just already have it in your head, you may see your null and alternate written out slightly different and not equal to each other, but equal to the value of 0. So let's just say if we are talking about averages instead, and I'm just going to look at just the null in this case. Well, usually we had mu equal to some value. Now we're going to have mu equal to mu. We're looking at two samples. So again, let's just say sample 1 and sample 2, or population 1, sorry, population 1 and population 2. Well, if I do that same math with the subtraction as it did for the proportion, subtracting mu of 2, subtracting mu of 2, and getting 0, another way to write out your alternatives, your null and your alternative, would be mu, and if you just label it mu difference, it's the difference between the two averages, equals 0. So if you see mu d or mu difference, that's why it's equal to 0, because you're subtracting that from both sides. So there's another way of writing out your alternative. You may see it. And I'm saying this because you may see it this way. I believe I do put on some of the answer keys just so you get used to seeing it. I prefer this one. The reason, because you are going to have both of these labeled, so it gives you more of an idea of what your populations are talking about. Population men, population women, of smokers, non-smokers. I think this gives you a better idea of what the situation is. Okay, but just in case you do see it, that's all this is just doing the math to bring your one average over and subtracting it. Okay, so that should be just a little idea of what your null and alternate should be, looking at the two samples, two population hypothesis testing.